Hello everyone, welcome to Alfonso Academy. I am Sapita Alfonso and this is the fifth part of the chapter Periodic Classification of Elements. When the properties of the elements in the groups or the periods in the modern periodic table are compared, a certain regularity is observed in their variations. These variations observed in the periods or the groups of the modern periodic table are called as the periodic trends in the modern periodic table. So today's part we are going to study the first periodic trend observed in the modern periodic table, which is in the valency of the elements. As you have learnt earlier, valency is determined by the number of electrons present in the outermost shell of the atom of that element. So let's consider the first 20 elements as per your syllabus and let's see their valencies. The first element is hydrogen with atomic number 1. So it has one electron in its shell, which itself is a valence shell, the last shell. So hydrogen can form up to maximum of one bond because it is having only one electron. So its valency is 1 because it can form one bond and combine with another atom to form a stable duplet, that is 2 electrons in the first shell. So its valency is 1. Next element, helium. It has atomic number 2. Its electronic configuration is written as 2 and its valency is 0 because its duplet is complete, that is 2 electrons in the first shell. It is already having 2 electrons in the first shell, so it is full, which is its maximum capacity. So valency is considered to be 0. Next element, lithium. Its atomic number is 3. Its electronic configuration is written as 2, 1. That is, it is having one electron in its valence shell, the last shell. So it forms one bond with another atom. It is very easy for lithium to lose this one electron which it is having in the valence shell. It loses its one electron and gets into stability. So for example, I have shown over there, lithium loses an electron from its outermost shell to chlorine, which has 7 electrons in its valence shell. The third shell of chlorine has 7 electrons. So it needs one electron to form a complete octet, to complete its octet. So lithium loses its electron to chlorine to form lithium chloride, which is a ionic compound. Ionic because lithium donates the electron and chlorine accepts the electron. It is not about sharing the electron. It is directly about donating the electron and accepting the electron. So lithium becomes Li plus after donating that electron. So its valency can be also written as +1. Chlorine's valency can be also written as -1 because it accepts one electron. So that is the ionic compound which is formed by donating and accepting the electron. So even the valency of chlorine is written here as 1 because this is the basic way to write the valencies. We are not considering the positive or the negative signs. So next element is beryllium with atomic number 4, electronic configuration as 2, 2. So it is having 2 electrons in its valence shell which it can donate. So its valency is written as 2. Similarly, boron has valency 3. Carbon has valency 4 because it can share its 4 electrons which are there in the second shell, the valence shell. It does not donate or accept 4 electrons because that needs more energy. Rather than that, it shares its 4 electron with another atom to complete its octet. So its valency is 4. Nitrogen has valency 3 and not 5. You must be thinking that nitrogen is having 5 electrons in the second shell, which is the valence shell. Its valency must be 5. But no, its valency is 3 because rather than donating 5 electrons, nitrogen accepts 3 electrons because it loses less energy to accept these 3 electrons. But to donate 5 electrons, it needs more energy. So nitrogen accepts 3 electrons to complete its octet. So its valency is written as 3. Oxygen valency is 2 because it accepts 2 electrons. It does not go to donate 6 electrons because that needs too much energy. Oxygen accepts 2 electrons, so its valency is 2. Same way, fluorine accepts 1 electron, so its valency is 1. Then neon has valency 0. Its electronic configuration is 2, 8. So it is already having 8 electrons in the second shell, so its octet is complete. So it does not need any more electron to get into stability. So its valency is written as 0. Sodium has electronic configuration 2, 8, 1. it has one electron in the last shell, which is the valence shell, which it can easily lose to another atom. So its valency is 1. Magnesium has valency 2, aluminium has 3, silicon same way like carbon has 4, phosphorus same like nitrogen accepts 3 electrons, phosphorus also accepts 3 electrons to get into stability or complete its octet, so its valency is 3. Sulfur has valency 2, chlorine has valency 1, argon has electronic configuration 2,8,8, so its octet is complete, that is 8 electrons in the last shell or the valence shell, so its valency is 0. Potassium has electronic configuration 2,8,8,1, its valency is 1, and calcium valency is 2. Now if you see this table, I have kept a small gap over here, that is to show that there are some more groups but they do not occupy any of these elements from atomic number 1 till 20. So elements from atomic number 1 till 20 lies in group 1, group 2 and group 13 till group 18. So there are groups over here from group 3 till group 12 which occupies the transition elements which have atomic number more than 20. And these elements, the first 20 elements lies in the period first period, second period, third and fourth period, first 4 periods. First period has 2 elements, second period has 8 elements, third period has 8 elements and fourth period has 2 elements out of these 20 elements. Now if you see the valency of the elements within a group, the valency remains the same. In first group the valency remains 1. All the elements in the group 1 have valency as 1. In group 2 valency is 2. Group 3 valency is 3. Then similarly group 18 the valency is 0. So within a group valency do not vary. There are no variations in the valency of the elements within a group. It remains the same. So this is the first thing you have to remember. And second, across the period when you go from left to right, valency varies. See, the valency varies 1, 2, 3, it changes. So there are variations in the valency as you go across the period from left to right. So these are the 2 things you have to remember well. So that's it in this video. Next video will be coming with the variations in the atomic radius and the periodic trend observed in the atomic size of the elements. So thank you very much for watching this video.